All right, so this is your review for your functions and exponents quiz. The first two problems you have are supposed to be sort of simple introductions to dealing with exponents. And really, number one deals with what we call the product rule, number two, the quotient rule, and number three, the power to a power rule. So the first one is just multiplying all of this stuff times all of this stuff. And so you have two regular numbers, the 5 and the -3. Those get multiplied together to make -15. So you're multiplying. A lot of people like to write 2 as an answer, multiplying those numbers together. That takes care of those. So then we have x squared and x to the fourth. Because you have an x term here and an x term here, and you're just multiplying, you actually add the exponents. So it's just 4 plus 2, x equals, or x to the 6. And the same thing for the y to make it y to the 11. And this problem is done. If you go to number 2, it's sort of a similar idea. You have 15 over 5. If you think of it without the x's and y's in here, just deal with 15 over 5. It's like 15 divided by 5, which is 3. So take care of the 15 and the 5. The rule for exponents like this, I say that these two cancel out all but one of these, leaving you an x to the first, or just an x on the top. And finally, these 5 y's cancel all but 2 of these, leaving you with a y squared on the bottom. And again, that's your final answer. For number 3, you have exponents raised to other exponents. This is one where you want to deal with that part first before you try to simplify anything else. So I would say this is x squared squared again. This is when you multiply exponents. So the first thing I'm going to do is take all the exponents in here and multiply them by 2 to get rid of that thing. So it's going to be x to the 4th. This is like y to the 1, or in other words, you just square the y. And then on the bottom, I have y to the 3rd squared. That's y to the 6th. Now with that answer, you can look at this problem and how we cancel out things. These two y's right here will cancel all but 4 of these, leaving 4 on the bottom. So we have x to the 4th on the top and y to the 4th on the bottom. And these 3 are done. These problems are meant to be just a little bit harder. Most of the time that means they're like a 2-step problem rather than just 1 step and done. For number 4, we have a few things going on. I have reducing of regular numbers, I have fractional exponents, and I have exponents that are negative. So I would say in step number 1, what I want to do is try to reduce these numbers or divide them if possible. In this case, they don't divide evenly. So I'm going to say 2 goes into both of those numbers. So that's going to help me reduce that to -12 on the top and 7 on the bottom. So this is a -12. It doesn't move or flip. Once it's done, it's done. But as I'm going along here, I have x to the 4th. It's positive, so I'm going to leave it there. But this y to the -6, that needs to move down below so that it turns positive. Okay, going to the bottom ones, x to the -3, again, that's negative. I actually have to move it up to the top to turn it positive. And this y to the 3rd is already positive as it is. So in one step, I've reduced the numbers and gotten the exponents to be all positive. And now, just like in that very first problem, this is x to the 4th times x to the 3rd. I'm just going to add them together. Exponents get added like this to the 7th here. On the bottom, I have 7y to the 9th. And that's the final answer. For number 5, I think people tend to make the mistake of moving the exponents that are negative down below right away. And it's okay if you do that, it will work, but I think sometimes that makes it more complicated. I like to multiply through everything first and then move the exponents if I have to. So I'm going to do -2 times 7 and get -14. The x terms, when I add those exponents, are going to give me x to the negative 11, and the y exponents give me y to the 6. Okay, that negative 11 I can't leave in my answer. So the negative 14 and the y to the 6 are okay where they are. I'm going to leave them on the top, and I'm going to move that x to the negative 11 down below so that the exponent turns positive. And that's your final answer for that one. For number 6, this time I have exponents and regular numbers all raised to an exponent, but that exponent out here happens to be negative. So I have to fix that before I do anything else. So some people like to make each one of these things raised to that negative second power. I'd like to get rid of the negative first by just putting this whole thing, moving it all down below the fraction and making it 1 over all of that stuff. And when I do that, everything in parentheses stays the same, but that exponent out there turns positive. And so now what I do is take this whole bottom thing and square each term. 12 squared, not 12 times 2, 12 squared is 144. Now I have an exponent raised to another exponent I'm going to multiply, so that's x to the 8 and y to the 12. That one is done. These are scientific notation problems, which a lot of times you can use a calculator for, but sometimes the calculator likes to round the answer, so you need to be careful that you're using the calculator for the right reason. For the case of number 7, scientific notation is really like one of the easiest things that we have to do. All you do is multiply the regular numbers together, and then we're going to add these exponent terms. So I'm just going to take 2.2 times 4.5 on my calculator. That's what you're using the calculator for. This one and this one multiply together, and I get 9.9. And then I add the exponent terms to get times 10 to the 16. That's the final answer. Number 8 is the exact opposite skill. It's dividing scientific notation. So again, I'm going to divide the regular numbers, but now I'm going to subtract the exponent. So it's exactly opposite of number 7. Here I'm dividing regular numbers, subtracting exponents. 16 divided by 4 is 4. And when I subtract, I'm saying negative 3 minus 4. Negative 3 minus 4 more means all the way down to negative 7. Now it's done. Number 9 has a little bit of a trick built into it, otherwise it's exactly the same as number 7. When you take 6.8 times 9.5 on the calculator, you get 64.6. And then we add the exponents to get times 10 to the 8. The problem is that you can't have a number here that is bigger than 10. It has to be between 1 and 10. Otherwise, you have a too small of an exponent over here. So all I do to fix this is move this decimal point back to the left one place. And I got 6.46, which is between 1 and 10. But when I move the decimal point to the left, I have to add to the exponent. So I move to one place, so I add one exponent. That's your final answer to that. So now we're done with exponents, and we moved on to the function rule thing. This one gave you math test scores, and it gave you names and their scores. So it asks you, is it a function? Is it a function to go from name to score? So I would say, if I'm thinking about it like a computer program or something like that, where I would enter in the name, I should get one answer if it's a function. So if I enter in Megatron, I get 84, one answer. That's good. If I enter in Bumblebee, I get 88, one answer. That's good. I would say that from name to score, this represents a function relationship. One input to one output automatically. Score to name, on the other hand, means that if you enter a score, you only get one name. You have to make sure that when you do this, You approach it from the idea of, can I make it so that it's not a function? So if I just check the 90 and I say, if I enter 90, do I get one name? Yes, I only get optimist. The way that works, it sounds like a function. But if you check it more thoroughly and you say 84, 84 gives me Megatron, or it could give me Starscream. Which means I could get two answers if I entered 84. That is not a function. So you need to actually say no, but you also need to explain why it is that you're saying no. So a good answer for this one might be something like, no, 84 gives two possible, or better yet, gives more than one possible answer. That's the way you describe a good specific function. So all of the rest of these things are all asking that same question. Is it a function or is it not a function? For number 11, I think if you look at it, you can see that the number 3 goes to 1 and it also goes to 0. So if you enter 3, you would get either 1 or 0. That is not a function. So the reason would be no. 3 gives more than one answer. How about number 12? Well, is the graph a function? The way you check a graph is to use the vertical line test. So I take a vertical line and I draw it on the graph. This is the graph of a rectangle. I have a feeling it's going to hit it more than once. You can see right there that the vertical line touches here and here, which makes that not a function. On the other hand, for this problem, there's nowhere where you could draw a vertical line anywhere, no matter where you do it, where it will really touch the graph once. You have to watch in here because it looks like it's touching it, but actually that vertical line will be running right next to it. It touches only right there. Same thing here, only one time. Any one vertical line only touches it once. That makes this one a function. Okay, so now we have a bunch of coordinate points that ask you, is it a function or not? What I'd be looking for is to look at the x-coordinates and say, if I entered 2, could I get any other y-coordinate other than 3? The answer is no. And you could say that same thing for each one of these x values. Each x value only gives you one corresponding y value. So as it stands, this is a function. Hypothetically speaking, if I were to add another point in here like this, then I could say, well, look, 5 gives me either 8 or it would give me 16 over here. That would make it not a function. But that point wasn't there. So as the problem stands, this is a function. So the answer to that is yes. So for domain, maybe you want to make a list of all the x values in order from least to greatest and don't repeat any of them. So I give a set symbol because it is a set of numbers. And it looks like -3 is my lowest x value, and then -1, 2, 4, and 5. And the range is the exact opposite. It's the y values, or output, in this case y values, from least to greatest, not repeating. So I have 0, I have a 3, I have an 8, another 8, and a 3. So it looks like I'm going to go 0, 3, 8. From least to greatest, no repeat. Okay, so we move on from that one into word type problems. These are kind of my favorite function problems because sometimes they have a real world application I guess. So we say from the day of the week to the number of hours in that day. I think if you think about this, you're saying any day of the week. If you enter in a day of the week, you get only one answer for the number of hours in that day. So Tuesday. If we say Tuesday, do we only get 24 hours as an answer. That's yes. If I said Wednesday, how many hours do I get? 24. Again, even though it's the same answer, that doesn't matter. What matters is if I enter one day, do I get one answer for the number of hours? Which you do. So this answer is yes. This is a function. If you look at it the other way around, you flip it around. We're saying, is that a function? So now we're going from the number of hours to a specific day. So if I say 24, well, does that automatically give me just one day? And that answer is, of course, no. You would say 24 hours gives me multiple answers. 24 could give me Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, or Sunday. So in this instance, if you take the number of hours a day, it doesn't automatically lead you to only one day, it leads you to all of them. That is not a function. Okay, so the last one on there, I thought this was going to be kind of like a joke. Wile E. Coyote is a famous cartoon character. He used to chase the Roadrunner all the time, and he always used to refer to himself as Wile E. Coyote Super Genius. He even had a business card that said genius on it, like you can see in the picture. So I think the joke was that if you say Wile E. Coyote, does it automatically lead you to Super Genius? That was supposed to be a yes answer. If you were to flip it around and say Super Genius to Wile E. Coyote, well then I think you would have to say no. Because maybe somebody like Isaac Newton or Einstein could come out of that. So if you said, look, say Super Genius, does it automatically give you Wile E. Coyote? Well, maybe to old Looney Tunes fans like me, you could say yes, and it could be a function, but you could also make the argument that it's no if you flip it around. All right, that's your function and exponent quiz review. Please, I hope you check these videos and take your time on the test tomorrow. Make sure you get rid of all negative exponents, and make sure that when you have an answer for a function that is no, you give a reason like I've been showing you here.